Unit 7 marks the halfway point in this series, and it also marks the last unit that's on syllogistic or Aristotelian logic. What we're going to do in Unit 7 are two things. One, introduce and use the strategy of Venn diagrams. It's a strategy, of course you know, for identifying the validity or invalidity of syllogistic arguments. And the other thing will be to apply those rules about the formal fallacies that syllogistic arguments can encounter. So, 6 problems using Venn diagrams to determine validity or invalidity. Here's our first one. All good sports are fair players. Therefore, since all golfers are unfair players, no golfers are good sports. Well, where do we start? Like many of these problems, we need to start by identifying the conclusion. We have therefore, which is a conclusion indicator, but again, here it's followed by since, which is a premise indicator. So what immediately follows the since is the second premise. No golfers are good sports is our conclusion. Now it's important to remember that when you do Venn diagrams, you do not diagram the conclusion, but you need to identify the conclusion in order that you can identify the terms. So with the conclusion no golfers are good sports, we now know that good sports is the major term, golfers the minor term. Why that's important is that on Venn diagrams you want to put the subject term of the conclusion over on the left lower side. You want to put the major term, or the predicate term, on the right lower side, and you want the middle term of the syllogism on top. That just standardizes the graphs, makes it a lot easier to correct too. Now, so we have to identify each of the terms. The minor term is golfers, so it may help actually to put a little indication down here of what term we're diagramming. The predicate term is good sport, and the middle term is fair player. Okay. Now with this in mind, we can do the first premise, all good sports are fair players. We need to diagram that. All good sports are fair players says that anything that is a good sport, or anything in this circle here, has to also be in the circle of fair players. That is, it has to be above this line here. It has to be in this intersection here. That of course means that nothing is down on this section of the good sports circle, and so the lines here indicate areas that have been eliminated or shaded out. So again, all good sports are fair players is diagrammed by showing that the only open area of the good sport circle is the area that also intersects and is part of the fair player circle. Now look at the second premise. All golfers are unfair players. Notice that we have to do a little bit more work here because we've got unfair players and not fair players. So the second premise here has to be changed. And remember, we did this in the last unit, Unit 6. So we need something equivalent to all golfers are unfair players, but which uses the term fair. And of course, you should remember, no golfers are fair players is equivalent then to our second premise, and we need to diagram this. No golfers are fair. Here are the golfers. None of them are above this line. That is, none of them are part of the fair players circle. And we show that then by eliminating that intersection, the little football area where these two circles intersect. Now we've got the diagram for the two premises, and that's really all you need to diagram. But we need to determine if the argument's valid or not. How do we do that? Well, we ask ourselves what we would have to diagram in order to diagram the conclusion. Remember, we don't place anything on the graph, but we ask ourselves what would have to be placed there if the conclusion were diagrammed. And here's the trick. If what you would have to place on the graph already is there, then you know the argument is valid. If you would have to add something additional to the diagram premises, then you know the argument is invalid. So let's see how number 1 goes. No golfers are good sports is our conclusion. That would be diagrammed by saying that anything that is a golfer can't be in the good sport area. In other words, to diagram the conclusion, we would have to eliminate this intersecting area. But notice that's already been eliminated. And so here's a case where the premises diagram already shows the conclusion's truth. That indicates the argument is valid, and so we write valid. Okay, well, let's do a couple of more. Number 2, some rice is long-grained and all long-grained cereals are good with milk. It follows that some rice is good with milk. Well, it follows that, of course, is the conclusion indicator. So we now know that the minor term is rice, because remember that's the subject of the conclusion. We know good with milk, things that are good with milk, is the major term. That means the middle term must be what's left over, long-grain rice. So we're just using these short words here to indicate or identify each of the circles. Now we have to graph both of the premises. Now, one thing is important here. You always have to graph a universal premise first. In other words, if you have a universal premise and an existential premise, you must do the universal one first. So the premise 2 here, all long-grain cereals are good with milk, is what we first need to do. All long-grain cereals, anything that's in here, has to be good with milk. In other words, it has to also be in this circle. Well, that part is of course this football. So we need to eliminate all of the circle of indicating long-grain cereals except that part which is also part of the circle good with milk. Now, first premise, some rice is long-grained. Remember, when you're doing existential premises, you don't use shading as a technique, but you use an X. You place an X in part of the graph. Some rice is long-grained is saying that something which is left in this circle also is in the long-grained circle. Well, the two parts of the intersection here that are possible is this one and that one. This one already has been shaded out. So in order to graph the first premise, we would need to place an X right in the middle area. This says there exists at least one thing, that's what the X indicates, there exists this one thing which is both rice and long-grained. Now we look at the conclusion and ask what we would have to graph if we were to do that and see whether it's already there on the diagram. Some rice is good with milk. Some things that are rice are in the good with milk circle. Is there anything already there? Yes, our X is in part of the area that intersects with good with milk, and so we've already got the conclusion diagrammed. That means, again, this argument is valid. Notice why picturing the premises can indicate the validity or invalidity of an argument is that if you consider the concept of validity, you're saying on the assumption that the premises are true, the conclusion must be true. The Venn diagrams are showing you the truth of the premises, and if in showing that, they've also shown you that the conclusion is true, demonstrated or diagrammed the conclusion, you know that that true conclusion is ensured by the two premises. In other words, the argument's valid. Number 3, on to something better than rice. Some whiskeys are not single malts. This can be inferred from the fact that not all whiskeys are made of barley, while some single malts are not made of barley. Well, the first sentence here is our conclusion. Notice that's indicated by the next sentence that says this can be inferred from the premises. So that means that whiskey is our minor term, and single malts is our major term. And what is the middle term? Made of barley Okay, now are we ready to go? Well, notice that this sentence, "not all whiskeys are made of barley," is not itself in standard form. Not all, right, is not either a, E, I, or O sentence. So we need to change that first in order to know exactly what to diagram, and you should remember that a sentence that's equivalent to this would be that some whiskeys are not made of barley. So let's put that over here so we don't forget it. Some whiskeys are not made of barley. And now we need to check the other premise, which is some single malts are not made of barley. We notice that's an existential premise also, so it doesn't make a difference which of the premises we start with. Let's begin with the one that we needed to alter. Some whiskeys are not made of barley. That means that some things in the whiskey circle are not in the made of barley circle, so they have to be underneath this crescent. We don't know, however, whether the X should be placed here or whether the X should be placed here. The premise, in other words, doesn't make it clear, doesn't assert that it's in one or the other of these adjoining areas, and that's the situation in which you put the X right on the line. This means something could either be over here or perhaps over there. Now the second premise, some single malts are not made of barley. That's the same type sentence, an O sentence. So we're going to have a similar diagram. Some single malts are not in the made of barley area. Well, they have to be down here then, but they can either be in this area or in this area, and the premise doesn't make it clear. Once again, we put the X right on the intersecting line to indicate that the X could either be in this area or that area. Now we need to determine whether this argument is valid or not, so we have to ask what we would have to diagram if we had diagrammed the conclusion. The conclusion is some whiskeys are not single malts. Some whiskeys are not in the single malt region. That is, they're not over here. They must be then over here, either in this area or that area. Now here's the question. Does the diagram as it stands diagram the conclusion? Remember, the conclusion would need an X here or an X there. Well, notice this X here could be in this area. Remember, when the X is on the line, that means that it's indeterminate whether it should be over here or over here. Well, if the X were over in this area, then there would not be, in this diagram of the premises, an X in the spot that is necessary for the conclusion to be diagrammed. In other words, there wouldn't be one here or there wouldn't be one here. Therefore, we'd have to add something more to the diagram in order to have the conclusion diagrammed, and that indicates that this argument is invalid. In fact, the fallacy that this argument commits is the fallacy of exclusive premises. You'll notice that both of the premises here are negative. Okay, number 4. All makeup artists are lovers of Tammy Bakker. Some TV preachers are not lovers of Tammy Bakker, so some makeup artists are not TV preachers. The so indicates our conclusion. That means that makeup artists is our minor term. TV preachers is our major term. And lovers of good old Tammy is the middle term. Now we look at both premises, figure out whether we need to do one before the other. We have a universal premise here. We have an existential premise here. So the A sentence has to be diagrammed first. All makeup artists are lovers of Tammy Bakker. All makeup artists have to be also in the lovers of Tammy Bakker circle, which means the bottom part of this artist circle has to be shaded out. Now we do the existential premise. Some TV preachers are not lovers of Tammy Bakker. That means there exists something in the TV circle which are not lovers of Tammy Bakker, so they have to be below this crescent, requiring an X to be placed in that area. So there's the diagram of the two premises, And now we need to ask how the conclusion would be diagrammed. Some makeup artists are not TV preachers. Some makeup artists, something in this circle, are not in this circle, the TV preacher circle. So for the diagram of the conclusion to be correct, we'd have to have an X over here. And notice that the diagram of the premises doesn't have that X. Therefore, again, we know this argument is invalid. Okay, let's do one more. Number 5, no squirrels are flying animals, while all cartoon characters named Rocky are flying animals. Therefore, no cartoon characters named Rocky are squirrels. Therefore, a conclusion indicator. And so, cartoon characters is the minor term. Squirrels, the major term. Flying animals, then, must be the middle term. And now we're set to do the diagram of the two premises. We look at them and find out that we have two universal premises, no and all. So it doesn't matter, again, which premise we diagram first. Let's do the no sentence. No squirrels are flying animals. Nothing in this area is also in the flying animals circle. That means you need to eliminate this intersecting football, indicating that nothing exists there. Now the positive premise, all cartoon characters named Rocky are flying animals. Anything that's a cartoon character named Rocky has to be up here in the flying animals circle. That means you need to eliminate all the lower area of cartoon characters named Rocky. And there is our diagram for the two premises. Now, what about the conclusion? Do we need to add something to the diagram, or is it there? No cartoon characters named Rocky are squirrels. No cartoon characters are in the squirrel section. To do this conclusion, we would have to have eliminated this area in the middle. Notice it's already been eliminated. So the premises diagram indicates the truth of the conclusion. We have a valid argument here. Our last three questions have to do with the formal fallacies that it's possible to commit with categorical syllogisms. So we need to check to see which of the rules, the 5 rules concerning these fallacies, has been broken. All conifers are firs and some conifers are evergreens. Consequently, some firs are evergreens. Now, because more than one answer is possible here, you will need to check each one of the possibilities to make sure that that fallacy is not committed. So, A, negative conclusion from affirmative premises. Well, this one can't be committed, can it? Because the conclusion, some firs are evergreens, is positive. So we're all right with A. What about B, undistributed middle? You commit the fallacy of